Okay, excuse me, that boneheaded of me the way I did this, okay? It's AX equals B. And B is your target vector. It's over there in R4, right? I mean, yeah. That's in R4. This is in R2, okay? And it wasn't making any sense in terms of the picture I just showed you that all of R4 collapses onto R2 and leaves you room outside the image space. Wasn't making any sense, okay? Because I was just not making the connection clearly. And while I'm at it, let me see if they're using what they're using C0 for and C1. Just want to do this in terms of their okay, your points are these. Okay, well, that's okay. Okay. So anyhow, now that my notation is consistent with the book and the dimensions of these things make a little bit of sense, which was what was troubling me, A has dimension what?
4 by 2.
It's 4 by 2. Okay? So, we're going to want this. Where C0 and C1 and I've got, in order to get this matrix right, I got to know what they mean by C0 and C1. Because one of them is your X and the other is your Y. Now your points are these, so that's your X. Okay, so I have it right.
Yeah.
Amazingly. Okay? You want your equation to be y equals C1x plus C0. Okay? Well, C1x would be C1 times 2, right? And you'd like that to equal 7. So I can write down the system. So you want, ideally, ideally you have this, but how many equations do you have? Yeah, you can count them. There's one for each data point. There are 4. How many variables do you have? 2. It ain't going to happen. So you want the C0 and the C1 that bring this as close as possible to being true. Okay? So your matrix is going to look like this. All these are 1s because you always multiply C0 by 1 because that's just the number you add, right, in your linear model. And your second column is going to be your X values, 2, 3, 4, 5. Okay? So you multiply these, and you hope to get these. So this matrix equation just represents this ideal situation, right? It's not achievable. You can't solve it. So what do? Well, C0 and C1 are vectors in R2. So you got like R2 here, right? And you're mapping to R4. Okay? You've got your image space, and you've got certainly a non-zero null space. Over here. You might not have a null space over here. Okay? There's no guarantee that this vector goes into your range space. Matter of fact, for real world data, you can pretty much guarantee it's not, because that would mean that you do have a solution to these four equations and two unknowns, which is not to be expected. Okay? So, you want to find the vector over here that's an image of some vector over here, which I'll call question mark, that's as close as possible to this subspace. Okay? Now, this is in R4, you can't visualize it, but it's like, okay, you're mapping R2 over here, so you got the plane. And all these points are in the plane, right? So you're essentially mapping these points over to this four-dimensional subspace, which will typically have a two-dimensional plane through the origin, okay? And an independent two-dimensional plane, which can't happen in 3 dimensions, okay? And this thing's going to map somewhere in that mess, but it's probably not going to be on the two-dimensional plane that's the image of this space. Actually, you know, wait a minute. What I just said is ridiculous. No, it isn't. That's range of A transpose. I don't know what I'm looking at. Okay. Confused myself again. Okay. So the question is, how do you find the vector here? It's an image of one of these that's as close as possible to this. It's a little complicated. But I want to get that question in front of you, okay? Because it gets pretty weird. But it's really kind of neat, if you can understand it. And you guys can, okay? If I explain it half decently. Or if you read your book, which is quite good, but you really almost need hand waving. You need to frame it like this so you understand the context of all these manipulations. You can understand this step, this step, this step. You can understand the symbols. You can even maybe bring yourself to believe it, but do you really understand it? Maybe. Yeah, depends on how your mind works. Okay? But we're going to try to really understand this. Make sense?
Yeah.
Oh man, we're 2 minutes over.